to break free. Oh, ready for the videoing. Sorry, I didn't realise. We'll, oh dear, got to do some cleaning there. Answers to the mechanisms questions. 3 separate videos, be 3 separate short videos with the answers. Free radical mechanism video, electrophilic addition, nucleophilic substitution, all year 12 focused, and we'll have the answers. I'll see you after the edit very soon. So here we are with the answers to electrophilic addition mechanism questions. First one, but-2-ene, and it's the Z isomer. HBr comes out, pushes that off. Carbocation with a plus there. Got to remember, of course, there are in skeletal formula, don't see any hydrogens. There are of course hydrogens in these 2 positions here, so there's a hydrogen there and 2 hydrogens there. Bromide ion goes in, joins on. Here's the formula of the product. There is no conflict. This is symmetrical, so putting the carbocation the other way results in this molecule just flipped around the other way. So it's exactly the same. So there is no mixed product, there is no major minor product issue. It is just, and it's all down to it being symmetrical, which is something we said in the instructional video when you watch that. So we're going to have a little edit. I'm going to clear the board. We're going to get on to B. See you in a moment. So B, bromine and but-1-ene. But-1-ene doesn't do E or Z, so there's none of that to consider. Double bond comes out, pushes the electrons down on there. We've got this induced dipole in the bromine molecule. Leaves us with the, now in the question it said draw the most stable carbocation. Well, this is the secondary carbocation, rather than having the plus on the very end of the molecule where the double bond is. So we then get, I mean, you would get the same product if you wrote the other carbocation. It's not that it changes the product, but it did say in the question, right, the most stable. So here it is. When you look at that, some people look at skeletal formula and go, oh, right, I've added an extra carbon in. So you've got to remember, 4 carbons in but-1-ene. 1, 2, 3. Still only 4 carbons and that bond out to the bromine, so it hasn't changed. People get confused by skeletal formula. I'm not sure you can see those numbers, are a little small. But we'll see you all for part C when I've put it on the board. See you in a moment. So, C. This time, the 2 carbonyl ions are important. Now, I realised after we'd finished the filming of the previous one, I'd forgot to mention that the bromide ion joins on. It's going to be the same in every mechanism, that bit where the positive carbocation picks up the negative anion. So here we have pent-1-ene, pent, 1, 2, 3, 4, 5 carbons, obviously it starts 1 at this end. So standard beginning, comes out, grabs the hydrogen, pushes the electrons onto the bromine, but it goes to 2 carbocations. Here's the primary carbocation, here's a secondary carbocation because it's got 2 carbons attached to the carbon with the carrying the positive charge. So this is the more stable of the 2. So that leads to this, where the bromine has gone on just like always. Here, that's the major and that's the minor with a curly I. So there we have 2 carbocations, different proportions of each, because this is more stable, it does more of the reaction. This one breaks down a little bit quicker, don't get so many of them doing the actual reaction. And there we have major and, not median, minor. D coming up after we've set it up on the board. See you in a moment. D, cyclohexene sulfuric acid. The mechanism, same but different, of course. Same idea obviously. Electrons come out, grab the hydrogen, hydrogen goes back to make a negative anion. The anion is the hydrogen sulfate ion. I can't count, that should say 4, don't know what I'm doing. And So we get the cyclohexyl carbocation plus SO4H goes in. There you get cyclohexene hydrogen sulfate. I did make an error with the name in the explaining video. Got it correct this time. So it is very similar in mechanism to the HBr mechanism. So there would be consequences for asymmetry, but of course cyclohexene is symmetrical, therefore putting the plus on the other end of the double bond, no change in the final product. You then use this to go on to make other chemicals, that's why you do this. See you for part E. So, E, more complicated chemical. Now one of the things A-level exam boards they like to do is occasionally they'll throw in a novel compound that you're unlikely to have encountered before. There have been quite a number over the years that have all got interesting backstories. I don't know the backstory of this one. Myrcene, this one's called. It's something to do with the plant myrrh and Christmas and all that business. But it's 3 double bonds. And it does say quite clearly in my question an excess of bromine. Now that bromine would need to be 3 times or more in excess because there are 3 double bonds to react to. Mechanistically, you're unlikely to get a question to do the mechanism, but you are likely to get a question where you would do the product. So each double bond will do the mechanism at the bromine, so it'll take 3 bromines. It will come out. Now I have drawn that's the most stable tricarbocation. Obviously you can move the plus to there. That's more stable because it's tertiary compared to secondary. Not a lot of difference between those two in terms of stability. This one, again, tertiary rather than the primary on the other end. And this one's secondary instead of primary. So you would get the other carbocations as well. And there are a number of possible combinations. I can't even contemplate, probably 10, something like that. But by the time you've finished, you put a bromine on either side of the double bond with the carbocation picking up bromines, just like all the other times we've done it in a mechanism. And so you get a bromine either side of where the double bond position was. You can therefore identify where the double bond used to be. There's another double bond there, there's another double bond there, which is what we've got up there. Myrcene, myrcene, I don't know how you say it. I'll see you for the last one. See you in a moment. Last one, F. Now, again, novel compound, camphene. It's got this strange bit in the centre. All that is 6-member ring with a bridging carbon going over between the top and the bottom of the hexagon. As with a lot of these questions you see at A-level, the majority of the molecule has little role to play in what you do. You just copy it from one place to another and focus on the reactive centre, which is in this case the double bond. So mechanistically, out it comes, grabs the hydrogen, bromine gets electrons pushed onto it, and then you can see it goes to 2 products. Here and here are 2 different carbocations. This one is primary, this one is tertiary. Tertiary is much more stable than primary, so this is going to lead you, once the bromine joins onto the carbocation, that'll be the major, that'll be the minor in terms of product, and there we are, 5 electrophilic substitution questions. There's still the nucleophilic ones, which is the 3rd video. And I'd like to apologise for the fact that I neglected to think about this, and we put the dishwasher on before we started filming, so it's been gurgling away in the background making its noise. Thank you for putting up with that, and I'll see you for the nucleophilic video if you've done those questions already. See you soon. Bye bye.